Hey YouTube, welcome back. Problem number 2268, minimum number of keypress. In this problem, imagine you have a phone with a keypad that has 9 numbers, numbered 1 to 9. Each button can have up to 3 letters mapped to it. When typing a letter, you press the button corresponding to that letter. If a letter is the first letter, so for example A, you press once. If the letter is the second letter, for example B, you press twice, and so on and so forth. So given a string called S, our task is to figure out the minimum number of key presses needed to type the entire string. So for Apple, we will take five times. So basically A, it press on button 1. P, we press it will be by pressing on button 6 once as well, and the other P. L, it will be by pressing button 5 once, and E, it will be by pressing the button 3 once as well. So a total of 5 press are needed, so we return 5. So how can we do that? How we can do that in the code? We can do this in the code by doing 4 steps. The first thing that we need to do is we need to count the frequency of each character. We need to count the frequency of each character. So we need to know how many times each character appears in the string S. This helps us prioritize characters that appear more frequently, so they can be placed in positions that require fewer key presses. Number 2, we need to sort the characters by frequency. So after counting the frequencies, we sort the characters so that the most frequent characters come first. This way, we can assign them to the position that require fewer key presses. Number 3, we need to map characters to keypad buttons. So we assign characters to the buttons, making sure each button has at most 3 characters. The first character on the button requires 1 key press, the second requires 2 key presses, and the third requires 3 key presses. And after that, we need to calculate the total key presses, which is the end. We need to calculate the total key presses. So we calculate the total key presses needed to type the string S based on our character to button mapping. So let's try to dive in the code. So first, I said map a lot. So let's create a map first. So I will call it frequency map, which will equals a new map. Okay. After that, I will make a count loop for count the frequency of each character. So I'll create for const chart of S, and I would say if frequency dot has the character, if it has it already, we increase it. So we will say frequency map dot set character to whatever the value is the character. So how we can get the value, we will see the value that get the character, and we add 1 to it. Okay. If we can't find the character in the map, that means it's a new one. So we frequency map, we assigned a value to it with 1. Frequency map 1 INA to make it set. Exactly. So right now we are counting the frequencies of each characters. After that, we need to sort the characters by frequency in deciding order. in descending order. So how we can do that? Let's say const sorted char, it will equals an array of frequency map dot entities entries dot entries, not entries, entries dot entries dot sort a b. Okay, we need to ab will take a callback function where b of 1 less than a of 1. So let's just try to describe this code a little bit. So first we said we're trying to sort the characters. So the purpose of this line is to take the character frequency data stored in the map, okay? And after that we should convert it to an array and then sort that array in descending order based on the frequency of the characters. This will help us prioritizing the most frequently occurring characters when assigning them to the button on the keypad. So how we do this? Let's first break it down. So first let's talk about this one. So we convert the map entries to an array. So frequency map the entries returns the iterator of the key value pairs entries in the map, and the spread operator is used to expand the iterator into an array. This creates an array of entries where each entry is an array with two elements. We have key and value, where key is a character and value is frequency. Okay. After that, we sort it. So we have this one. We have the second one is sorted. The sort method sorts the array in place. The sorting function a, b, and b, the first element, the second element and b, and second element at a. This one, the sorting function, compares the second element of each entry, which is the frequency, which is the value of the frequency. And we have b of the index 1 and a index 1 as well, ensures that the array is sorted in descending order of frequency. If b of 1, if b of 1, the frequency of the second entry is greater than a of 2, which is the frequency of the first entry, the function returns a positive number, indicating that b should come before a in the sorted array. If b of 1 of b at index 1 is less than a of at index 1, the function returns a negative number, indicating that a should come before b. If b of index 1 is equal to index a of index 1, the function returns 0, indicating that their order does not need to be changed at all. So let's continue doing the code. Right now we did sort the array. So let's create two variables. I will create a total Keypresses. I will call it total, and it will be 0, and I will return the total because I always forget to return values. So let me just make yeah, that's way more better. So we need to create another variable. I will call it button index, which equals 0. Let's continue. Okay. Well, let's create a for loop. Let I equal 0 and 0. I is less than sorted character dot length. Okay, and I plus plus. And in this one, we will try to first. We said that we saved our array will be will basically look like something like that. Right now we sorted the array, so our array will look like something like that. So each array, actually each element is array with the character and the frequency of it. So what should we do? Let's see. We should first have const, and we have the character and value. So character and value, or frequency, let's call it, which will equals, it will be in the sorted of I, exactly. And I would say the total, let's call it the keypresses. I need to know the keypresses. I'll create another one called keypresses, which will equals math.flow button, this button index divided by 9 plus 1. Okay, what this mean? So in this one here, the purpose in this line is to calculate the number of keypresses required to type a character based on its position in the button mapping. This calculation ensures that each character is mapped to a button, and the number of presses required to type it is determined correctly. So in our keypad, each button can have up to 3 characters, okay? And we have 9 buttons. So the number of key presses required for character depends on its position on the button. So we press 1, press 2, or press 3 times. Given these constraints, the line of the code helps determine how many key presses are required for each character based on its overall position in the sorted of the list. So let's just try to break it down. First, we have button index. The button index is a variable that tracks the position of the current character in the sorted list. As we iterate through the sorted list of the characters, button index increased by 1 for each character. We have the math.floor. In this one, math.floor button index divided by 9. The button index divided by 9 calculates the zero-based index of the button group that the current character belongs to. So since each button can have up to 3 characters, every 27 characters, like 3 characters per button, we have multiplied by 9 buttons, we complete one full cycle of button groups. And the math.flow rounds down the result to the nearest whole number, which gives us the group number of the current characters. For example, if button index is from 0 to 8 belongs to group 0, and from 9 to 17 belongs to group 1, and so on, so forth. And after that, we adding 1, because adding 1 adjusts the zero-based group index to 1-based count of key presses. This means characters in group 0 first, which is the first 9, require 1 key presses each. 1 key presses each. So characters in group 1, next 9 buttons, requires 2 key presses each, and so forth. So let's continue here. So right now we know the key presses for each character. Okay, after that we need to add to the total. So the total will equals plus equal the key presses that we have, but multiplied as well with the frequency, because we have other characters that could be frequented over and over, divided by frequency, and after that we increase 1 in the button index. button in the button index plus plus. And I guess it's mostly done, but I guess some of you might ask why we increase the button index by 1. So the purpose of the button index plus plus is to keep track of the position of each character in the sorted list as we assign them to the button. By incrementing button index with each iteration, we ensure that we correctly calculate the number of key presses required for each character based on its position in the sorted list. So first, as we said before, the button index is used to track the current position of the character in the sorted list of the characters by frequency. After that, we said that we calculating the key presses, the number of key presses required for the character. And after that, we increment the button index. After processing each character, we increment the button index to move to the next position. This ensures that when we calculate the key presses for next character, it correctly reflects its new position in the list. Example of that, let's have like an apple string, for example. And we have in Apple, we create this frequency characters, and the sorted array will look like this as well. And the iteration steps, it will be, for example, we can take P, which is P will equals frequency of 2, and the button index will be 0, and the key presses will be 1, and the total key presses, it will be 1 multiplied by 2, because the frequency is 2, it will be 2. So we increment the button index to make it 1. So when we have, for example, a second character, I guess the character that I created is wrong, because this is a character is not after sorted. This is a character after sorted. So when we go to the second element right now, the second character, which will be A, which is frequency of 1, will have button index of 1, and the key presses will be math.floor button index, which is 1 divided by 1, which is 1 divided by 9 plus 1. It will be equals 1 as well. And after that, because it's math.floor, and yeah, and after that we will add total key presses, it will equals 1, and the button index will get plus plus, it will equals 2. So when we get to the third element here, it will be the button index equals 2, and the key presses, it will be 2 divided by 9, which will be 2 divided by 9, which will be math.floor plus 1, which will equals 1. And yeah, and we continue so on and so forth until we reach each one. So yeah, let's submit the code and see if it will work. And it didn't work at all. It didn't work with anything, and let's see why. Let me check why it didn't work, because it should work. We have the characters of map, and we have set the sorted character with the frequency, the entries, the sort A, B, and B of 1 minus A of 1, and we have let total and let button index equals 0, and let for let I equals 0, I is less than sorted characters, sorted character, the length I plus plus, and the constant character and the frequency are in the key presses math.floor index divided by 9 plus 1 key presses. I don't know how in hell it doesn't work. Why? It should work. Key presses, the total equals plus equal, not equal plus, I guess. Yeah, exactly, plus equal, not equal plus. So yeah, that's it for this video, and I hope you like my content. If you like my content, subscribe and hit the notification bell so you'll never miss a video, and see you in the future.